Should I find it somewhere? Good. Perfect. Few people. Okay, I'm getting started, right? It's time. I'm going to get my diet. So, last week we talked about dynamic slicing, which is refinement of static slicing. And the main idea is we compute slices based on a specific program input. So the slices which we compute are only going to be value preserving for the specific input for which we compute our dynamic slice, which is in contrast to static slicing, which is much more conservative, much more general, which computes a slice for all possible program inputs. It doesn't make any assumptions about the program input. The advantage of dynamic slicing, the slices can be smaller. They must not be smaller, but they can be smaller. Obviously, depending on the input and what we execute. We also saw some examples of the challenges for dynamic slice. One of them is space complexity, because every program execution, every statement which we execute creates a node in our dynamic program dependency graph. So if we have a program execution which is 1 million lines, millions executed statements, our dynamic program dependency graph would have 1 million nodes, which is in contrast again to the static slice. The space complexity is number of statements, not of executions, but for every statement in the source code, we create a node in our program dependency graph. Okay, good. Not going over it. I updated the graph after my second iteration. It finally was correct. Because it's always tricky with also with PowerPoint. Sometimes I'm moving around stuff, but it's correct now. I also will post for assignment 4 a sample solution.
Sample solution.
Not yet.
Okay.
Because I was just working on the score potential, but we can go over one of them already.
Sure.
How about that one? And I will post for both questions a solution. Let me make it readable. Wait. I can handle that one. If the computer reacts, right?
Yes.
I'm waiting. I press the button. It's going to happen. See? It's my previous button. I want actually maybe page that. Sorry about that one, right? But it's out of my control. You will. Did it move? Ah. We are in 2022, right? I'm trying to scroll. I'm just announcing it just in case. Because I would like to. I hated it. Yeah, no. Sorry about that. One more. It's an adventure. Scrolling becomes an maybe one more, right? It should be good. That looks good, right? Readable. So, execution trace. Given is an input. Now we don't see the input, but you might recall it. Anybody can tell me what the input was? I was at 3.
Z is equal to 5.
Set to 5 and y to 7, right? Good. So we basically run the program on our input. I is less than z, right? So it goes. The first 3 statements are executed. Statement number 4 is true. Statement number 5 is true because I is 3 and y is 7. When we go in here, in statement number 6, done, 9, 10, we go back to the beginning of the loop. Now I was in the increment by 1, I is now 4, y was 10, right?
Firstly, I less than Z.
So I is still less than z because that is 5.
Again, it is
I is less than y, no? Yes.
Y is 7.
Yes. It's now
Again, going to Y.
we go into the med part, right?
And goes to 9.
Then we go to 9, 10, and last time up, I is 5, y is 5, I is not less than 5, we are done. Our
But then
trace.
why professionally took 7, 11 because it's not in the execution trace. It never comes on else.
Oh, it never goes to else?
No, because I also have following only.
Now my old graph is wrong. Okay, I did it before the lecture, I will update.
Yeah, sure.
Because now moving around, so really the trace, yeah, it never went in.
It's 1, 1.
It never went into
7.
8, right?
Yeah, 7, 11. Else 1. It never went to else.
Yeah.
And no 8.
That should be actually
It's 1, 1, 2.
6, right? It should be 6.
It is 6, 6, and then 9.
Yeah, I cannot. Yeah, I will update it.
You can update.
We will talk it next. I will
Yeah,
talk about it
sure.
next week, next lecture, because I just did it before, right? And I was rushing
No.
because I thought I could finish it. Good. Let's go back. But really, the main idea is once we have the trace, right?
Yeah, we can go on.
We just traverse backwards. Always just looking for the last data dependency and for the last control dependency. And once we have the dynamic dependencies on the whole dynamic program dependency graph, you just traverse from your point of interest backwards all incoming edges until you cannot reach any. Similar what we did for the static, right? So it's actually the same principle, except that dependencies are now on the dynamic dependency graph, based on the runtime, right? Okay. And the only thing you have to watch out, which is really exceptional, is between the while statements. Make a double control dependency. Just do it. Don't ask, just do it. And the reason is that way we guarantee that our dynamic slice is going to be terminated. Because it might end up in a problem if we go only through it once, right? It might end up with an endless loop.
Yeah.
Good. So like I meant, scared. Wait. No. I had a couple of mistakes in the slide. But again, it's funny because I had actually the original program dependency graph was for my PhD defense. With all the mistakes in it, and nobody noticed it at that time. So I updated it, and it's actually correct. Now, what we talked. That's where we actually stopped, right? Approximately. So one of the challenges was here, right? That was my example where we finished. And what we have here is a simple program with two loops, right? Nested loops. But our trace would become basically going in mammalian. And so in order to compute now a dynamic slice, you would have to traverse a million nodes, basically. And you can see, in order to create the graph, you should keep it in the main memory, right? Now, I know we do have a lot of memory these days, but that's not a short program, right? It's not a lot of nodes, because it's just two loops, right? Some programs run 24/7. You have billions of executions, so we cannot really record typically a complete execution trace with all the information what we need. So that's maybe when we get into a dynamic forward slice. And here comes one of the dilemmas of software engineering. Overusage of terms, of terminology, ambiguity of terms. Because now, based on our understanding, right, we had static slicing, backward slicing, we had static forward slicing, right? We had dynamic backward slicing, what we did in the assignment. And now what would we assume with dynamic forward slice? What would be our assumption? You know, if we follow the same terminology and the same, we would just assume it's again the same dynamic dependency graph, right? And we would just traverse all outcoming edges. And then we get the impact, right? Now there are some papers which actually do exactly that one, right? Just create a dynamic version, but really the term dynamic forward slicing, when it was created, meant actually something different. And what it does is actually it tries to overcome the space complexity of a dynamic backward slice. So it still computes a slice by considering the whole execution up to the point of interest. So it doesn't look forward like in the static. It still just computes a regular dynamic slice. Okay. The only difference is it will not require the recording of a program execution trace. So therefore has a much, much smaller space complexity. Okay. The basic idea behind the dynamic forward slices every statement is a block. Every complex block, which is an if statement, basically where we had before our brackets, right? Everywhere where we have a control dependency becomes a complex, becomes also a block. And the general idea is, if one of the nested blocks is included, then the outside block has to be included. Initially, all statements are excluded. So that's the assumption. And then only once a statement is included, one block is included, also the outside block has to be included. So if that block is included, B8 is part of a slice, B7 has also to be part of a slice, B6 has to be part of a slice. Okay, so that's the basic idea. The algorithm itself is actually fun. It's actually, initially it looks complex, but in reality it's really simple. And we make it very simple. We have our program like before, right? We have some program input, the same as before. We have some given an input. I'm not sure if I show it. It's the same input like before, right? It's the same trace as we had before. And now we execute the program. What the dynamic forward slicing algorithm does, each time when we execute a statement, it computes slices for every variable. Not just for one variable, for all variables. Okay? So if you have A, B, C, D, E, F, G in your program, it will compute each time the slices for A, B, C, D, E, F, G. Okay? Whereas the dynamic backwards, we only picked at one point, right? And then we compute the slice only for that variable. Here we compute at runtime for every statement a slice. Okay. Now, how does it look? It's a subset here because otherwise it would have been too small. But I will provide another example. Okay. So what we look is, before a statement is executed, at the beginning, all the slices are empty. Now we start executing our first statement. And we look what variable was defined. In the first statement, what would have been defined is N and A. Now, I don't show it here, but what actually should be for variable A, the slice would be now 1. For variable B, for variable A, it would be also 1, because that's where the variable was defined. Let's move to the next statement. Maybe I'll write it on the blackboard. Let's do a small example on the blackboard, and it becomes actually easier. Use the blackboard. Let's have a simple program. Let's have a couple of programs, right? And we will see exactly. Oh, that shall be light. Very good, right? We start very simple. I do a couple of examples, okay? Oops. B plus. Okay. 3 statements. So we have 3 variables. We have I, B, and C. Initially, slices for all variables are empty. Okay. Now we execute statement number 1. What is defined? I. So statement number 1 is actually changing the value of I, right? So it's relevant for I. Good. So what we do is, after executing statement number 1, the slice for variable I will be 1. Statement number 1 has no impact on B and C, right? Because they are not changed. So the slice for B and C actually remains empty. So that's now after executing, right? Now we're executing statement number 2. What is defined? So what we do is we update the slice for B. Has I changed? No. So the slice for I remains the same, and the slice for C remains the same, because nothing has affected it was relevant for C yet, right? Good. Now we execute statement number 3. What happens? 3 is defined, right? But now we have used variables, right? What is used? B and I. So now what we do is, now we look at the used variables, and we take the existing slices for these variables which were used and do just a union operation. Basically, merge these values in here, because these 2 variables were used, and our new set becomes 1, 2, and 3. Okay? It's set operations, what we do. Just unions. Now let's add another statement. Let's have fun, right? I keep it simple initially. Now let's do what? Right? So what is changed? I. So statement number 4 has to be included, because that's where we define I, right? What is used? B. So what we do is we look at the current slice of, I should have actually, let's do the same. So they are the same level. So what we do is B is used. So now we move actually B in here, right? The slice for B was not touched, right? We only used it. We did not modify C. I'm just using regular brackets. Okay, good. Now what happens? See, now we can play around, right? It's fun. Okay. I equals 5. New slice. I is defined, right? 5 has to be included. What is used? Is any other variable used?
No.
No. At that point, the relevant statement is only 5, right? I mean, which makes actually sense, right? If you compute a slice here for I, it should only be statement number 5. And the other ones didn't change. One more, right? Change C again, huh? Yeah. How about that one, right? I think when we have the initial, the basic of a forward slicing. So what is changed? Is I changed? No. Is B changed? No. What is changed? C, right? So C has to include 6 because that's when we change the value. What is used? C. So what we do is we move that one down, right? Which is 1, 2, 3.
No.
And what is used?
Right.
And we include also I, which is the 5. Right? So it's union. And if you have duplicate numbers, right, it only goes in once because it's a set. So that's very simple. Agree? Not complicated. And the interesting part, you have a slice each time, right? The current slice for all variables. All dynamic, obviously, depending on your program input. That's why it's dynamic, right? Because we execute the program. But given the input, we automatically calculate now slices for all programs, for all variables, and we don't have to record the trace because we do it at runtime, right? You say, I'm interested for that, like a debugger, right? You put a breakpoint and it will compute the slices up to that point and then here's it. Good. So these programs are cool. However, what we are missing is an if statement at least, right? We are not going to do loops. We are just doing if statements. I keep it very simple forward because for loops it becomes a little bit too tricky. Okay, let's have an if statement. Yes.
Professor, where is the dynamic part here? Because
I provide an input. Let's say. Yeah, because right now we didn't have any. It didn't matter, right? Because it's a sequential program. But now I have to because I'm going to add an if statement somewhere. Okay. But it really matters, but now my input is I equals 5, B equals 4. And I change a little bit my program, okay? Yeah. I leave the top part. The first 2 statements I leave, right? So the first statement now, if I is larger than B. Okay. I'm not continuing yet because that's a complex block, right? That's a block for us. We know that there's something inside which is control dependent. Agreed? However, for the dynamic forward slicing, since we computed at runtime, we don't know what's going to happen. Agreed? That's the statement what we get. Now let's look. for that statement, we don't know if there's going to be anything relevant later on for any of the variables, right? So what we do is initially, we have to consider that that statement might be relevant for any of the variables. Only once we leave the block and we see it was not relevant, we can say, okay, we eliminate. But we don't know what's going to happen, right? We cannot predict the future. So what we do is initially, now we don't have C anymore right now, right? Let's keep it simple. Because I have only A, B. So what we do is we include statement number 3. We say that block might be relevant for any. What is used? I and B. So what we do is again, we have to include I, we have to include B. Same. And anyways, our current slice. Can I add another variable? Yes, that's it, number 1. Let's have C, right? Oops. C is 0, right? C is 0, and because I didn't want to change everything else. It's number 0. Good. Now for C, what we do is, again, we have to include 3. We have to include, we keep the current slice, just in case. We just move it. So we take what we have and just add. Okay.
So even this variable is not used, we have to.
We will see in a sec. Now we execute, right? Let's say statement number 4. So you move just down your existing slice and then you add statement number 3 and whatever is used. You pick. What should we do in statement number 4? I plus plus.
Okay.
So right. So what happens? I is defined. So we would have to include 4, right? What is used? I. So we take 1, 2, 3 down. All the other variables remain the same. Good. It looks like fun. Now if we close it, the bracket, we leave, right? We leave our block. And remember what I showed you before, right? That's what we actually have. Agreed? And what I mentioned before, if that block, right, is relevant, the outside block is relevant. Now, in our case, if we compare between the begin and the end, these two sets are not equal, right? They're not equal. What it means is something happened in the block which changed the slice for that variable. And then what we do is basically at the end, we keep it because that block was relevant. Because the variable was somehow changed within that block, with that complex block, right? So we need it. There was one relevant statement in it. These ones, are they the same? So what it means, nothing has changed with respect to that variable. So they are actually equal, right? So what we can do is actually, that whole block was not relevant, right? It's not, we can remove it. So what we can do is we can actually fall back to the value prior. The same here. Begin, end of that block, they are the same. So nothing happened for that variable within that block. So what we can do is actually eliminate it and go back to the previous value. That's the basic principle. And if we have another nested block, you would just create it, you would just have to include it again. Same mechanism. It's really, once you understand it, it's very simple. You just look what is defined, what is used. If it's a block, you just include it. You take the old set, the original value, you take that statement in it, number 3, and all variables which are used. At the end of that block, you compare. If begin and end are the same, you can remove it because nothing was relevant for that. That variable never changed. If they are not the same, you keep it. So it's really mechanic, right? And by having not any while loops, I can keep it very simple for you, okay? But the whole idea is the algorithm doesn't know what's coming, right? And I think you saw it, right? If I add a statement, it didn't know, right? You didn't know what statement, right? So the algorithm has always included initially, say, okay, that if statement might be relevant. It only knows at the end, once we leave the if statement or the else statement. So any type of complex block, it only knows when it's not relevant. I will give another assignment, okay, to practice. But you will see, it's I will give you 1 or 2 small examples, right? Preparations. Obviously, I will have it in the final, right? I will post the don't worry, I will post the coverage, but I will also provide you with 1 or 2 questions, which I might ask, more of the textual description, comprehension questions. Not only about slicing, about configuration management, DevOps, right? To give you an idea what type of questions I will ask. Just to practice, get you ready. But if you recall it really midterm, right? It's going to be assignment and exam questions are going to be correlated. Not the same, but the same style, right? Okay, good. So now we have a little bit more context, right? I'm going to dim the light. Remember, I did not put all the variables, right? I don't have A, I don't have I don't have N on it, right? Okay. I should have A, but stupid. Anyways, I will provide it, I will update it. But it's the same idea, right? And like I said, I will not have a while loop. I think here I have a while, I will have just if else. They can be nested, but I will give you an assignment. Because with while loops, in theory, we would have to do some extra work, again, to make it executable. So that's why I leave it out. So for dynamic forward slicing, there's not going to be a while or for loop. Okay, it will be just if else statements. Good. So much. So the advantage is we don't have to create a complete dependency graph. We just keep sets of statements, right? So which is a really, the space complexity, memory complexity is much, much lower. Computational complexity might be still high. So why? Because we could still have a 1 million executed statements, right? So we might calculate 1 million times, right? Slices. Now set operations are quick, but still, right? It's just the number of executions will be impacted. Dynamic forward slicing. The main challenge for that one is loops we can deal, but if you jump out of a block and you never finish, like exception handling, becomes very difficult, right? How do you guarantee that the program is executable if you never reach the points, the end part, right, of a loop, the end part of the block, because you're jumping out, right? Exception. On 0, right? On division by 0, right? On buffer overflow, whatever, right? Whatever you put in, right? You typically jump out of your regular program flow somewhere else, right? And you never terminate that original block. And that was actually what I did for my PhD, right? Dealing with these jumps, unstructured programs. And here, now let's look at some of the challenges for static. And a lot of these challenges of static slicing are actually resolved by dynamic slicing very nicely. Arrays. You have an array with 1,000 elements. Static slicing has to treat the array, all variables, has to consider all array elements because it doesn't have the runtime information. What is the value of I? A of I, it doesn't know what I is. It has to assume any value, right? So if your array has 1,000 elements, static slicing has to consider 1,000 A's. A of 1, A of 2, A of 3, because it doesn't know. As soon as you say A of I, right, it doesn't have the value of I, so it has to consider all possible scenarios. Same for records, fields, you have the same thing, right? Because it's dynamic, right? You might define static slicing has no problems. Dynamic slicing can overcome these problems because it actually has no runtime information. It knows which fields. It knows concrete, right? Like a debugger. A debugger knows the values of all the variables, right? You can pinpoint a specific array element. Okay. So far, what we have looked was only simple programs, and which is also going to be part of the exams, only simple programs. The reality, however, is we have programs which are not only a main program, right? You have functions, you have objects, and you have functions calling other functions and functions passing parameters by value, by reference, depending on your programming language, right? If you go C, C++, pointers. Pointers are what? Memory addresses, runtime memory addresses, right? You can have a pointer to a pointer in C, C++. Static slicing has no clue. it doesn't know what it's pointing to, because you need runtime information, right? Because it's referring to memory addresses, and then again, that memory address might be resolved later on, right? If it's a pointer to a pointer. So in these cases, static slicing becomes very, very tricky to calculate even proper slices. Number one is passing values. You have in your main program, you're calling a method A, you're passing B and C. However, in your method header, you are assigning it to C and D, right? So the slicing algorithm would have to make sure that it actually maps and knows that A and B map actually to C and D in your function. That actually A and C is the same and B and D is the same, for example, right? So the algorithm would have to make sure that it actually can map these function headers, these function references. Okay, tricky. So extra challenge. Again, dynamic slicing, it's easier because you can get the memory address. You would actually see that it's actually the same variable. So what you would use in dynamic slicing, you would not use the variable names, you would actually use the memory address. So if there is something passed by value, you would know it's actually the same, or by reference, you would know it's actually the same variable. Dynamic slicing. Static slicing, very tricky. Also for static slicing, or in general, in both cases really, in static and dynamic, if we go into procedures, we have actually one additional dependency. What we would have to introduce is something which is called a call dependency, which works very similar to what we did actually with our dynamic forward slice. If you have one statement in a function being relevant, the function has to be relevant and the call has to be relevant, right? So if you execute the program, it's easy. You call a function, and if something in the function is relevant, the function header or function body has to be included, but also the call. So when we talk about in the procedural slicing or system level slicing, we would have something which is called the call dependency. So we don't have only not just control dependencies and data dependencies, we would have also something which is called call dependency. So here's just an example what it could look like. So we have three procedures, right? Procedure one calls B, B calls C. Okay. And then, you know, so if C is included, you're interested in here, that part will have to be partially included, and that part has to be something included in order to create an executable program, right? But I think you see the challenge, right? You're interested in here somewhere. That one has to be included because you want an executable program, value preserving, and then parts from here have to be included. But don't worry, we're not computing slices for the procedural slices. Because then, you know, the graph becomes more difficult and you would have our dependencies. Unstructured programs go to exception handling, creates extra challenges. Even recursions for static slicing, it's very difficult to figure out, right? What's actually happening, which of iteration, how often you're going in and figuring out the flow. So something like here becomes difficult because they are actually called, right? And then you terminate. Other extensions of slicing, which are also partially tried, partially done, but where overall are still challenges, obviously, are multi-threaded programs, distributed programs, where you have additional challenges in terms of synchronization, ensuring that the states remain the same in your slice as in the original program. Who's calling whom? Message passing. Static doesn't know, has to consider basically everything, right? Dynamic can resolve some of it. Very large systems, scalability. Now, static slicing has been used for C and C++ programs of decent size. There are some slicing algorithms. There are some for Java, but they are commercial. What also people have also used slicing a lot of in formal methods, where you basically in model check, where you are checking if basically every state, if your model is complete or correct. And the way slicing was used is model checkers typically, the problem is the state explosion. You have too many possible states which you have to consider. And so what people said in model checking, I might not be interested in everything. Just give me basically the states which are relevant for the mission critical task. And then make sure that these mission criticals are actually complete, that we consider all possible states for these mission critical states. So what we did was we applied slicing on the original model to reduce the number of states which had to be checked. So similar what we do actually in the program, your point of interest might be not just a variable, might be a state, might be a certain function, because it's mission critical. And then you extract basically all the states which you want to make sure they should be checked if they can actually be reached, if they're reachable, and if you have actually considered an action which is happening. So if you have a complete requirements or specification. Okay. Good. Our challenge, obviously, if you don't have the source code, what do you do, right? If you call an API, but you get something from the API, right? But you don't know what's happening within the API because you don't have the source code, you cannot slice it. Obviously a challenge. Good. Switch in context. Complete switch. We did software evolution. We try everything, right, to keep our software going. We looked at DevOps, right? We looked at different ways of comprehending, reducing technical debt, right? But at one point, we might decide we are done with our current system, right? And so what we are going to look at is now, what are we doing if we actually start thinking about retiring? Migrating, maybe to a new system, right? What is involved and why would we do it? And then we look at a small case study. So, I've seen it, right? Legacy system, old system, which is still relevant, which is useful, and we want to keep it. We typically have a long lifetime. We talked about it, but also legacy systems, often when technology is out of date. Absolutely. For various reasons, right? But they are typically also what's the business critical. So what it means is we cannot just retire them and not replace them. We have to think about something to replace them. So it's not just giving up on the system, right? We have to find an alternative. And then how do we implement the alternative? How do we deal with alternative? So that's actually referring to the legacy system. Let's look at some of the data from the US, and it's actually interesting. So the US Government Accountability Office identified the 10 most critical federal legacy systems which should be modernized. Age of system in years. So we are still used. 46, 50 years old. And we are still in use. Hardware, 18 years old, hardware. Good luck to find the spare parts, right? System, how critical are they? Various, but what we also see, a lot of them have some security risk associated, right? So there's a need really to change them. So we know we have security issues, but we cannot maybe solve them anymore because we don't have the necessary skills or the technology is not there, right? But it's just amazing to see, right, that there are plenty of old systems still out there. And a lot of governments, but also companies. Any large organization has still corporate programs. We are still doing often payroll. They are still doing some of the tax programs on a regular basis. First, what we know, right? We should change. It was our aging part, right? If we change it, if we don't, systems have to adjust, right, to the environment in which they live. So, but largely, these are often large systems, the legacy systems, developed by different teams, by different developers, different programming styles, different technologies, old, right? Obsolete. No system documentation, or if they have system documentation, it's not maintained. Corrupted, right? Technical debt, unstructured, ignorant surgery, techniques to save space and increase speed at the expense of understandability. 50 years ago, how much computer memory did we have, right? How much RAM did we have? The systems. Not much, right? So they were working on register bases, right? Moving around bits and bytes, really individual bits and bytes, trying to optimize the memory usage, optimizing the speed. Most of us have no idea, right? How many of you have worked really on assembly, right? Low-level assembly, right? We like our high-level, fifth generation programming languages, drag and drop, right? APIs, but we don't go down anymore at the register level, typically. Old file structures, right? Databases are old, nothing. And just to give an impact of maintenance, right? The US government, 80% of IT expenditure is on maintenance. So we are not talking about a small portion of the budget, right? It's a huge budget which is actually just used. Mainly includes aging legacy systems, which are often somewhat efficiency, cybersecurity, and mission risk issues. So a lot of them, because of the degrading structure, right? You don't have people, changes take longer and longer, right? So it's really the typical scenario. What we talked about in the course, it's reality. Which is actually what large organizations face. So it's not done. So completely updated. As a result, initial anticipated increase in maintenance. So originally we were expecting from 21.8 million to 35 million, turned into 34 million annual savings. So we were expecting to spend up to 35 million, right, annually for the maintenance, for the evolution of the old system. And after modernizing, replacing it with a new system, they only spent 1 million every year. They say 34 million a year. So you have initial investment, right? Didn't say how much, right? So maintenance and support, often after 5 years, it's more than the original development. So maintenance and evolution really, it's not for your small app, right? It doesn't really matter if you only keep it for 1 or 2 years. You don't worry too much. But for anything really which which organization want to keep, it becomes an issue. Failure to comply with industry regulation could potentially lead to millions of penalties. If you have a legacy system which no longer meets certain requirements, could be certification requirements, could be having certain logs providing user data whatsoever, right? Which has been updated by law, you might have to pay a penalty because your system doesn't provide the necessary information. Security. Average security breach, approximately 4 million. Lost business opportunities. Because what we end up is actually lack of innovation. If you keep your old system too long, yes, it might be running, but the competition might have actually, they might have a newer system. They can add functionality, new functionality, which you cannot actually support. Like most simplistic would be a web interface, right? But it could be much more functionality, smartphone support, app support, whatsoever, right? You might not be able to implement it as part or integrate it in your old legacy system. Also, the average efficiency of some processes can increase up to 50% for automation and modernization. So that could be on your software side, but could be also on the application side, when you actually run the application. Because if we look at our software, right, with DevOps, right, we talk about automation, but you need an infrastructure which actually supports, right, that type of automation. Interesting, right? So that's the same thing, right? So we just trying to motivate that you actually very an important course, right? But we address some important aspects. So legacy systems tend to be large, cannot easily be changed or replaced. Often a small update. So that's when we talk about ripple, right? That's when we need impact analysis and ripple effects. Y2K can have a big impact. also figuring it out, right? If you have documentation, you might have thousands of pages of documentation. I did, oh, that's now 10 years, maybe 15 years, so quite a long time ago. The US government, the US military forced all the US military agencies and all alliance partners, including Canada, to follow the DoD standard for documentation and traceability. So what they provided was a template of documents which have to be provided with every software project. Now the template itself, so I'm not talking about the documentation. The template was 800 pages describing what type of documentation you should provide, you have to provide. The reason why I'm mentioning it is some of the military, government or military systems have really thousands and thousands of pages of documentation because they were actually mandatory as part of the development. And even during maintenance, they have to be maintained to establish traceability, to make sure if something is going wrong, that we can try to figure it out. Also, what they dealt with was with a lot of consulting companies. The military typically does not develop their own software, or very little. They outsource it to third parties, right? So we had to make sure that it's so that they could do security checks, right? Anything else. Good. Infrastructure getting old. So you can see data represents also another significant infrastructure because the data might be spread out over dozens of different databases over time. Why? Because, give you an example, mid-90s, no, was it now? It must have been in the 80s. Mid-80s, sorry, after the German reunification. Germany had to change the postal codes. All postal codes were only 4 digits. The new postal codes were 5 digits because the old one was just not sufficient, right? So they changed all the postal codes. And at that time, I was doing my master's degree in an insurance company. My thesis, and what they did was they used that time to figure out, to look at the existing databases. Because what they realized was they had 40 or 50 customer databases. So we had 40 or 50 databases that we had to update the new postal code. Huge redundancy. How did it happen? It was actually easy. People developed a new application, right? And we said, hey, I don't want to mess around with production data initially, right? So we created this, so we cloned, we copied the original database, made their own copy, and then we started maintaining our own copy. We were running it off their own copy. Done. And that was actually the same here at Concordia. When we introduced the SIS system 5 years ago, what we ended up was so many similar databases or containing parts or duplicate data, but often inconsistent data. In some data, basis, for example, an address was updated. In a number one, it wasn't. A phone number updated, not, right? So it was actually a mess. And we also basically cleaned it up at one point. So a similar procedure, right? And I will talk about it later. Staff training. The old COBOL programmers are gone, right? So you have to train new people in exciting COBOL programming, right? You would be all jumping, right? Job offer, looking for COBOL programmer, right? You would be excited, no? Would you apply? No. Most of you wouldn't apply. First, you might not have a background, right? And even if they offer you training, you would say, why would I learn something which is obsolete, right? So very difficult to find people, right? Connecting a legacy software to a third party to services often requires significant amount of custom code. Compliance. You might have new privacy laws, new security laws, right? Which you have to follow. And that can actually become what? A death spiral for your legacy application. Because you might not be able really to implement it, right? You might have to make so many changes and you don't know where. And the structure of your old code is done, right? And you might have to update it. And so they did. So these are the different standards. One is for European, one is for Californian. Just aligning, right, to the new requirements. 38% of the organization said it's a problem, right, to align the infrastructure. High effort implementing these requirements, 36%. High cost to achieve the alignment, 33%. So it's a major factor, right? So basically up to 40 or 42% of organizations are actually having problems. Once ever, and that was just one example of privacy. Privacy could be, you cannot, you have to black out SIN numbers. You have to limit, right, who has access to personal information within your organization, etc. With your third party, and just implementing these changes. Also, legacy systems are often less resilient to cyber attacks because a lot of them networking, maybe initially, right? But internet and anything afterwards was typically just an add-on, depending how old your system is. So we were never designed from ground up with the internet, with the cloud, for example, as a main part, right? It was added on later on. But like so many other things, if you retrofit something, you're renovating a house, right? Sometimes, no matter how much you do, if the structure is not there, right? Even your renovations will be so-so. If the outside wall is crooked, it's so much more difficult to make the walls inside straight, right? And similar here. Also, another reason is that outdated software might no longer be supported, right? If you still run your Windows 95 server, you might be in big trouble, right? Because you might have no security patches for the last 10 years. So here's just an example, right? Of an example of lost technology or whatever. Traditionally, we had our main branch You might have a call center, online, mobile, but it's all connected to a main branch. Very simple. And now what we have is really the smartphone is in the middle, right? Becomes your main interface of dealing with other parts. Okay. So that's how it changed, right? And if your IT infrastructure doesn't support it, you're done. So often we don't have any choice, right? We will have to move to modern technology infrastructure. Like I said, we talked about DevOps, right? If you want to enable the agility, we want to have continuous integration, continuous deployment. We have to move away from the old-fashioned approach and technology. So it can hold back innovation, customer loss, and it's also less efficient. Good. So why are we not just going and scrap all the old legacy systems? Because now, so far, everything says, the legacy systems are bad, right? So why did the governments not just get rid of the 50-year-old systems? Why are we waiting? What are we waiting for? Business risk. You don't want your business to suffer or down. If your migration fails, your business goes down, depending on the application you're migrating, right? Like in November, December, when Concordia switched to SAP, I was worried that I'm not getting a paycheck because they actually migrated to a system for payroll, right? And they want us, there might be a slight chance, right? Now, I would be happy if I don't get paid, right? But that would be still okay. But now if you are, and I would get paid afterwards. But what about transactions? What about if you have a mission critical system, right? Air traffic control system, you're migrating, you cannot afford, but it goes down suddenly, but it has faults in it, right? So the challenge is, yes, we might have documentation, but how much can we trust it? And how is it up to date? So here we go back to the vicious cycle between agile, right? Agile promoting no documentation, having also, or here traditional process waterfall oriented models where we have a lot of documentation. We have to find a good middle, right? And most importantly, if you have documentation, it should be consistent, it should be updated. You cannot leave it just on the back burner, say, I created during the development and never look at it again. Otherwise, it's useless. Okay? At the same time, if you don't have any, it becomes even more complex, right? You have nothing. All what you have is your test cases, otherwise, and you have your issues. You try to figure out what somebody did 20 years ago. Why? Very difficult, right? And we don't have any ideas yet how the traditional agile extreme programming and even DevOps will handle that one in the long term. We don't know. We hope, right? But mostly it becomes an issue of just small deltas, right? We say just by taking a smaller delta, right? Yeah, but that's during recurrent evolution. But what happens if you have to retire it anyways? How do we figure out the requirements? With what are we going to replace it? See, people haven't looked that far yet, right? People look at the current, right? At the instant gratification. How can we improve agile, overcome the problems? Which is perfect, right? We have to overcome them. But people haven't really looked at that issue of, let's say, migration, right? What happens if we actually have to retire? And we don't know what are the requirements. What is the business logic which we implemented? Why is that function calling that function? Why are these features dependent on each other? If you have to figure that one out just from the source code, good luck, right? Because source code is just a representation of a business logic. But doing that reverse engineering, right? From the low-level source code to come back to the business logic becomes really difficult. You don't know the laws, right? You don't know the regulations, why, etc. So we need something. We need additional information, and which is what I would consider still a problem which DevOps really hasn't addressed, right? Or data ops or model ops. It's mostly concerned about the day-to-day evolution, making things agile, making evolution agile. But we still have to at one point, right? Also, often you cannot just modernize one system. You might have to modernize all of your systems, or at least a larger part of your organizational software. Simple thing, you're updating your operating system. Let's go with something very basic, right? But you might have to update not only one machine, not only one server, you might have to update really all of them to make a consistent environment again. Because there might be incompatibilities. You can not only update one database from a relational to an object-oriented or to a graph database, you might have to update multiple because they have to communicate. They have to have data exchange, etc. Dependencies. However, if we are not only updating one, we have to update multiple applications. The scale and the risk obviously goes up, right? Because now we are not only touching one, maybe we are touching maybe 5 applications, 5 business areas, 5 critical areas. Skill shortage, right? So especially now, if you have nobody who actually, so you have no documentation and nobody really understands the programming language even. What are you doing? Right? Somebody who can actually fully understand what the source code does. If I give you COBOL code, Fortran code, assembly, even after a while, you might be able to read it sometime, right? But how much, right? Because somebody who might have programmed it before was an expert. They did optimization, right? Which is very difficult for you to figure out as a novice or beginner or with lesser skills. I think when it should be 7 o'clock, right?
7:10.
7:10. See, let's have a break after that one, right? I'm not asking for much, right? 7 o'clock. Yes. I'm I'm missing it. He was always telling me, right? You were all relying on him. So here's the dilemma. It's expensive and risky to replace the legacy system. It's expensive to maintain the legacy system. Business must really weigh the cost and the benefits. So there's not one single solution, right? There's not one single formula saying, okay, now you should replace or whatever. It really depends on the context. 5 minutes, 10 minutes break, or should we have a break or finish earlier? I leave it up to you. You tell me.
We can finish early.
We finish again 10 minutes earlier, 10 to 8.
Yeah.
Huh?
Yeah.
But then you tell me, right? No, seriously, otherwise I go till 9, right? 10 to 8, 10 to 8-ish, and we have no break, or you want a break?
No break. Finish early.
I don't care. I think you notice. I didn't even notice what time it is, right? So we already talked about, right?
Yeah.
So that's a lot, quite repetitive. It's just different viewpoints, different explanations of the same thing. We have to. We should, right? For various reasons. Good. But important also, they are social technical systems, meaning they are not just applications. They often involve also the hardware on which we run, right? So you cannot replace only one thing. Often you have to replace both hardware and the software. You might also have to replace utilities. You might have to change other application software associated with your legacy system. Application data has to be maybe changed. And policy and rules might have to be changed. So it might actually affect also your business itself if you do a migration. Why? Because when you use software, either might not work the same way the old one does. Some of the processes, business processes, have to adopt actually to the software. And that's what happens when companies move to enterprise resource planning systems like SAP, PeopleSoft, Oracle. And what they often do is replace their old business processes, like say payroll, right? Who signed off, who moved one thing to the other person, and adopted actually to the enterprise resource planning system. So businesses change to adopt to the new software internally, right? Could be no credit card check, even for your online store, right? It might work differently. It's done at a different point of time. Warehouse control system, right? Checking the inventory. You might have checked it only whenever somebody put something in the cart and was ready to check out. In your old system, you only checked at that point of time. Whereas in the new system, as soon as somebody puts it in the shopping cart, the inventory is reduced, right? And the item is reserved. Different ways, right? So you might change the way your business is working. So that's basically some of what the structure could look like of legacy system components. And I think that's an important part here, which a lot of people really underestimate. It's the embedded knowledge of business policy and rules. If you are not documented, how do you figure out what the software actually does and why? So, and then if we look, actually, there's different layers. We have hardware, we have the support software, which could be operating system, we have application software, and on top of it, we have the business processes, which take advantage of application software. Now, having such a layered architecture, in theory, we should be able to change one layer without actually having to change the other ones. That's the premises or it's the premise of a layered architecture. However, that only works if the interface doesn't change. But in most of the time, the legacy application, the interface will change, meaning certain functions are no longer available, which are used by the upper layer, right? So the upper layer can no longer provide that functionality, some functionality, which might go and it ripples through the whole system. Good. Not talking about it, I talked already. And that's what a really legacy application might look like, a legacy system, right? You have multiple programs, multiple data files, whatsoever, which are using, interacting, having maybe some dependencies. Cool. We could have a database centered system where you have your central database, right? So maybe a repository style, a blackboard style architecture. Then you have the programs which are a little bit more independent, but still the repository becomes the main. Or, you know, if you change that one, everything else will have to change. And that's another, these are just examples, right, of some of the legacy applications, what they could look like. You have an ATM and terminals, which do some teleprocessing, so remote processing, and then they update. So it's a client server, maybe a 3-tier architecture, right? So there you have your client side, client tier, you have your application tier, and you have your data layer or your data tier, your database server. So these are just examples of more traditional software architecture or legacy systems. Good. Legacy data could be in different formats, files, hierarchical databases, relational, object-oriented, graph databases. Now, these are not necessarily old databases, but I'm just saying. Good. So some companies are still using the traditional tools, right? Just because we have them, we have used them. So even computer-aided software, engineering tools, early case tools, some companies are still using them. But overall, obviously, legacy systems will not be easy to adopt to service-oriented because we have functions-oriented or even traditional object-oriented. We don't consider complete decoupling of the services, that services could be outsourced. You know, they are not meant to be, right? Based on the also traditional context. Obviously, before we perform any type of migration, we should go and estimate, right? We have to figure out how much it will cost. Do we have a budget, right? Is it the right time? How expensive? Do we have resources for this year? So The most expensive way to modernize is not to modernize, but as in any software development, we have to usually estimate how much it will cost. So one which we could use is the Kogumo model. ADIS is still used today. It's basically, the idea is it's a very simplistic formula. And the idea is the formula can be adjusted, has a couple of adjustment factors depending on the programming language, which considers the expertise of your development team, how complex the system is in terms of functionality. Also, it would consider the timeline, how quickly things have to be done. And the main part of the equation would be, however, the size of the system, the size you are, how big the system is, which you are going to change and migrate. Then another one classic model would be the function point analysis, where you try to estimate the cost for migrating individual functionalities, and then you sum it up. Right, so you look at how much will it cost me to change that function, to move it maybe to a service oriented to a cloud. Okay. And then you basically add it up. And then there's the Putman model, allows for estimating the time and effort needed to finish the project if you know its size. But again, estimating the size, knowing how much the size of a new system is for testing, development, and very difficult. A lot of these models are very imprecise, meaning plus minus 30%, it's a good estimate. Okay. So, and typically what people do is they use different types of cost estimation, migration estimate models to determine the actual cost. Alternatively, you can hire an expert. An expert, and that here, big companies, assuming again, you are switching from your proprietary software, payroll, human resources, warehouse, whatsoever, to an enterprise resource planning system like SAP, right, or PeopleSoft, right? What happens in that case? They do have expertise. They have historical data, right? They know how long, how much effort it was for our customers. They can give you actually a very good estimate of the initial cost, how much the migration will cost. So you can consider them an expert, right, of a migration. And then what you can do is you can get 2 or 3 different companies, right, to provide you an offer, like you would do in any other project. But that's when you outsource, okay? If you do it in-house, you would have to use more traditional. Or you could hire an expert who has done similar projects in the past somewhere else. Okay. Also, companies have to obviously assess the legacy system which we are going to replace, to determine if they should maintain it, if they should replace it, if they replace the system with a new one, transform the system, to re-engineer, to improve it. And then what we would do is basically look at the business quality and at the system quality. And then you try to figure out in which of the bubbles the system would fit. So system quality could be a technical debt, right? Could be the structure, etc. How long does it take us to maintain, to make a change? And then the business importance is an impact, right? So if you have something which has low business value and low quality and high quality. You might say it might be not really that important, right? Right now to migrate. Agreed? Because the system is of good quality and has a low business value. So why should we actually go for it maybe, right? So you define your criteria. Maybe you say anything, which has low business value and low quality, we want to change. Or that one, low quality and high business value, right? But you need first some type of classification. I mean criteria which to help you determine if you should actually, what you should do. Okay. So you have to do an assessment of the system quality and an assessment of importance. So if it's low quality, low business value, you might say just get rid of it, right? And replace it. Maybe you don't need it at all. If it has no business value, why do you have it? Maybe you don't need it, right? Or you can replace it easily with something new. Low quality but high business. So here, you might have high risk of affecting your business. So maybe re-engineering or find a replacement with a suitable system should be the way to go, right? So if you don't find a suitable replacement system, you should probably re-engineer it, clean it up, remove technical, restructure, and just keep it. High quality but low business value, you can replace it maybe with components off the shelf. Scrap completely or maintain whatever, right? High quality, high business value, continue operation using normal maintenance. You also should take different viewpoints in account when you talk about business value, because for different people it has a different value, right? IT manager, end users, etc. You can read. Give me 10 seconds break. Okay. And then business process assessment. Use a viewpoint approach and seek answers from system stakeholders, whoever is involved with the system. Is there a defined process model which is followed? The different parts of the organization use different processes for the same function here in your product. So your application might provide maintaining the customer database, right? But then the payroll or sales might use it in different contexts in their application, right? For different things. Payroll, you might pay your sales manager, right? Your salespeople, etc. So, and then you have to look, is the current processes, are they actually good enough supported by our application? What are the problems? If you want to migrate, right, where would we like actually to improve? Can we improve maybe? And then for the environment assessment, a whole set, right? Performance, age, failure rate, maintenance cost, interoperability with other systems. Can we understand comprehensibility, documentation? What about the data? Programming language, right? You can. I will post the lecture notes, that part. Anyways, good. Also, what you should do is before you actually do the migration, you need some real evidence, right? So keep track of your issues. Look at the failure rates. Look how long it takes you to fix a bug, right? It's our average time figure of fixing a bug going up. So you have to have some empirical data, real data. Good. Talked enough about that one, right? No video. So I'm skipping that one for the time being. I will come back to them either today or next week. How do we do time, guys? I want to have something exciting. First. For system migration, there are different replacement strategies. One could be a reverse engineering model. So where we are starting to gradually migrate to a new environment, but where we really migrate the data at the end. So here we start with the application itself, with parts of the application, and modernize one part at a time, and would leave really the data until the end, migrating all the data. There's a decision model, renewal process based on technical and some metrics, and you try to prioritize which part should be. You have DevOps contribution. So if we have the information coming back from operations, right, which can help us determining what should actually be next in line for migration, and also help us to look out something from a new application to avoid the mistakes of a current problem. So DevOps is not completely out of it, right? So that would be one approach which helps us. DevOps has the insight how good our old legacy system is, and it can drive the new development to avoid these mistakes and problems which we have with the current system. The Renaissance model is a two-stage process. So first, building a strong base for the system evolution, often with re-engineering, and second, apply continuous improvement. So with a Renaissance, we clean it up as much as we can, technical debt, reduce technical debt, do refactorings, clean up your structure, redocument, and then use the new renovated system as continuous maintenance. And Warren's maintenance upgrade is a customer-centric model which uses mainframe maintenance strategy based on customer satisfaction. So you ask your customer how happy they are, and they drive basically what should be updated and migrated. If customers are no longer happy, and all what it is basically just helping us prioritize, trying to figure out. So if you want to modernize, you have a revolutionary method around developing and carrying out the legacy system replacements. And it requires shutting down the old system and building a new one from scratch. So that's the revolutionary, and the evolutionary is a step-by-step process. We only replace parts of it, and then replace the next part. Okay. Important for both, we have to make sure that our business doesn't go down. So often what you would do is you would run the application in parallel. So you will not shut down your old legacy system, you let it run, and in parallel you run your new system. Okay. And at one point you might migrate to a new system, but you run your old one as a backup in parallel until you're sure that they are actually working. So you have two systems in parallel, right? And it can also be used, just to make sure for testing, right? Very simplistic, right? Is my old system providing, is my new system providing the same output as my old system? Until you have enough confidence that you actually got most of the bugs out. That's what we have, right? We have the old legacy system, or what you want is everything better. That can be taught, right? More or less. I think the last 1.5 hours, 2 hours, I talked enough about these ones, right? It's just a different viewpoint, but it's really the same, right? Just in a nice summary structure. Good. So, and really common requirements for migration, minimize the risk. Really, at the end, it's minimizing the risk for every stakeholder. User should not be affected, your organization, your business should not be affected, your operation should not be affected. And when we talk about deciding on migration, also what we have to consider is these 3 dimensions. Do we have any automations available? Automation could be you're migrating. You're saying, okay, I just want to modernize my old COBOL application to Java. Are there any tools maybe which do a conversion even of your old system? Possible, right? Another dimension is the domain, which has an effect. Generic, specific. Is the application something generic? What we can find basically also on the component of the shelf. Similar products are out there, right? Or is the application something very specific, proprietary to our organization? A database would be very generic. A weather forecast system for me, which maintains my cycling, which gives me, every second a new weather forecast during my cycling route would be something very specific, right? You will not be able to find a replacement. It could be proprietary, right? So you might have to rewrite it. A database, you can replace it with something else. The scale, obviously, it will have an effect. If it's something small, 10,000 lines or 10 millions, it will affect your migration strategy. Okay. Good. Let's look at my example. 2 banks. Bank A buys Bank B. Cool. Good. Now you're hired to help the banks to integrate each other. Cool. So, what could we do? So, both banking systems are very similar in terms. They have bank accounts, customer database, account database, right? We do something very, very similar. And now your job would be to help merging these banks. So that's what it looks like, right? So bank A, bank B. Database, data, at the bottom top you have your application. What could we do? The challenge, however, Bank B might have an investment accounts on top of it, right? A brokerage account. Bank A has mortgages on top of it, the regular business. So they have savings, checking account, both, right? Have savings and checking accounts. That one has mortgages, that one has a brokerage. So what could we do?
We can, instead of trying to merge into one, we can start creating one new C component in which we will start putting the components and then make it a integrated system. Like bit of A components and with the bit of B components, and we start putting it in C, and then we can make it an integrated system.
So you would create a
new component,
Yeah.
merging the two systems.
And where would it be? It would look the
Some
same.
part of A, like obviously we have same type of model structure of banks, but their internal structure of framework will be different.
Yeah, because we don't match, right?
Yes.
And they don't match.
So
Let's
we
look.
will take some time.
Yeah, you're close. Let's look at some scenarios, right? So really, you can see it. You cannot even see the arrow. There's actually arrow going from the right to here, right? Because that's what we actually want. We would like, to some extent, that the customer of B can actually access the application, some of the functionality of A, right? But the customer of A should have access to the functionality of B, but we also want probably that the data, right, should be exchanged between these two, right? And maybe that A and B should have some similar interface, right? Good. So we know now. There's some work, some approaches. One approach would be what? You could merge this data, right? Dangerous. Playing around with data is dangerous, we will see. Or you could make these two databases communicate. Data exchange, right? So if a customer has both, you could merge it, or you give access to both. Also, what we want to do is on the top, A and B should have access to the functionality, right? So your customer A should also be able to access brokerage information, have a brokerage account. So what you should provide is maybe a new interface, right? You could update the interface for A with providing now a new function, right? Having a brokerage account, and by the brokerage account might be still maintained here. Right, so you run two separate database systems in parallel. And you update the user interface for A, refresh it, right, and provide a functionality, open a mortgage account, right? But the mortgage account is maintained here. So you would actually run in parallel with two applications. Is that good? Is it what we want? Probably. What is the objective of a merger at the end? Why do companies merge?
You can have access to both the
To expand your clients, right? Number of clients. You want to have a larger customer base, but also
profit.
to save money, right? Because in general, that's why typically unions are very scared, right? If companies are merging, because typically a merger is always coming along with cuts in the staff, right? Suddenly, you might not need two branches, right? Even physical branches. If they're next to each other, before we were competing banks, right? After the merger, they are actually the same bank, right? Why would you have two branches next to each other? You close one, right? You have a savings. Similarly, probably we would like the same thing in our IT, right? And maintenance. Right now, we would keep both maintenance teams because the one team takes care of that one and the other one of that one, right? They have the expertise. But probably in the long term, we would like what to combine, right? To get rid of some of the employees. Okay. So both of them, that's how the systems work, right? AP. So one approach would be convert everything to A or B, right? Whoever is your better bank, right, has a better system. Convert databases, retrain the staff, who you need from the system B. Probably you have to enhance a little bit your hardware of A because you have now more customers, right? You have now the brokerage function which you're supporting, which you didn't have before. And at one point you can discard hopefully B completely. That would be one approach. Build an interface between the databases in system A and B, so that they can basically communicate. You still keep the different accounts in the different databases, right? A client could have even 2 accounts, but with the interface, it might look like only one. And then the other one, extend the client software so that it can interact with either system, A or B database one, right? So that would be to keep the databases completely separate, and just the interface becomes a merger, right? But really, the application, the functionality remains the same. The problem with making the databases work together seamless is always that the data is incomplete, might be, most likely, typically, will be not compatible. Example, account ID, account number. Bank A might have 9 digits, the old one has 11 digits. Names, customer names. The other one has 12 characters, the other one has 25, right? As the first name, last name, whatever, right? So what we need is probably some transformation, right? Some form of wrapping. And then we need an adapter which converts the data. So it will not change the data, it will just make sure that the data is compatible. That the same query can now be run both, etc. Should we stop? I said 10 minutes earlier, right? And we will continue here next week. So the game plan, next week, we talk a little bit more about migration. We will talk about migration to the cloud, specifically. And then I will we have 2 more lectures. The last lecture is going to be mostly a review for the final. Okay. And next week it's about migration and maybe special topics. Okay. If I find something interesting, I don't know yet what, but I will find something interesting, which I'm interested and cover it. Okay. I will post another assignment. I will post about forward slicing. I will post the solution for dynamic slicing by tomorrow. Okay. The correct one. I have started, but I will make sure that the trace is correct and my graph is correct. And I'm going to work soon, hopefully this week with your paper reports. Okay. Good. Any questions, any comments? Everybody quiet, everybody happy, everybody wants to go home. 1 or 2 days of cold weather, and it's supposed to get warmer on Thursday, 30 degrees
It's allowed.
for a day or two. Okay? Good. Thank you. Have a nice evening. Stay healthy, stay out of trouble. And my computer froze. Uh-oh. My recording didn't work.
Did not start it.
No, it froze. I no idea what happened here. Anybody? I'm looking for volunteers, but it doesn't look good. I didn't double check.
It's hand.
Uh-huh.
Okay. Just click on escape. Tab can help you moving here and there. Tab key. Actually, they cannot click anywhere.
Oh, no.
Cancel. Now it works.
I'm not sure. I don't know.
And it's asking for end.
Yeah.
Is it recorded? It is. Well, it's, I think, stopping.